Hey guys, welcome back to Hustler's Algorithm. Today we are going to be solving this problem, minimum average difference. So you can go through the problem statement in order to understand the problem. But basically what it says is we are given an array of integers, and at every index we have to divide the array into two parts. That is, let's say at 3 we have to divide this array such that one part will be 253 and the other part will be 953, and in such a way we have to divide the array at each index, and the average of the first part and the average of the second part is to be calculated, and we have to return the index where the difference between these two averages is minimum. So let's understand this with an example. So this is the given test case. So we'll calculate the sum starting from the first index till each of this index. So let's start. So here it will be 2. Then the sum ending at this index will be 5 plus 2, which will be 7. Then till this index will be 3 plus 7, because 7 is the sum from 0 to first index. Okay, so the total sum here will be 10. Similarly, we'll calculate the sum for each of these indexes. It will be 19. Then here it will be 24, and here it will be 27. So now we have the prefix sum for each of these indexes. Now at every index the number of elements in the left part will be I plus 1, because here the I is 0 and the number of element is I plus 1, which will be 0 plus 1, which is 1. Similarly, we have the elements at each of these indexes. Now the elements in the other half of the array will be n minus I minus 1. So the average will be prefix sum till this part, which will be 2. Then the number of elements here, which will be 1, because I plus 1, which will be 0 plus 1, is 1. And the remaining part sum will be 27 minus 2, because 27 will be the sum of complete array, and we'll subtract the sum of this index, so we'll get the remaining sum, so which will be 25. And the number of elements in this subpart is n minus I minus 1, which will be 6 minus 0 minus 1, which will be 5. So it will evaluate to 5, and here we have 2. Okay, so let's calculate its absolute difference, which will be 5 minus 2 will be 3, right? So similarly we'll calculate this for all of the subparts. Now one thing to remember is when we are at this last index, so the prefix sum will become this part, and as there are no elements in the later part, so we'll have 0 elements. So when we calculate the sum will be 0, so we cannot divide it by 0, so we'll get an exception, right? So in this case, if it is 0, then we'll simply convert it to 1, because 0 divided by 1 will be still acceptable. So let's code it down. So I'll maintain an array which will store the prefix sum. So we are maintaining a long array because here the constraint of each integer is given to be 10 raised to 5, right? So we may come across a condition where we have these two elements as 10 raised to 5 and then 10 raised to 5. So here the prefix sum will be some sum plus this 10 raised to 5. Now when we add this sum to this previous sum, it will overflow, it will cross 10 raised to 10, right? So in this case our int will overflow. So to prevent this condition we are using long here. Now let's calculate the prefix sum. So the prefix sum for the first element will take it as it is. Now let's calculate the prefix sum for the remaining part. So we have this prefix array ready. Now as we have to return the index, we'll maintain the index. Let's initialize it as -1. Now we have to return the position where the difference of the averages is minimum. So let's maintain the answer as integer dot max value because we have to return the minimum value. Okay, so now let's iterate to the nums. So the first elements will be I plus 1 according to this condition, and the elements in this later part will be n minus I minus 1. Now the average of the first part will be prefix sum or that part divided by the number of elements in the first part, and the prefix sum for the later part will be prefix sum of the n minus 1 because at n minus 1 we have the total sum of the array minus the prefix sum at this part divided by the number of elements in the second part, right? But what if our the second part number is 0? So if L is equal to 0, not L, S, if the number of elements in the second part is equal to 0, then we have to simply take it as 1, else we'll take it as it is. Okay, so now let's maintain the minimum index. If this is the case, then we'll maintain the min as this sum, and then the id will be this current element id. Okay, so now we can just return the minimum element, minimum id. Yeah, so seems good. Let's test it. Okay, we have to make this long as well. Let's use this as long. Okay, so we have to give a bracket here. Yeah, and here it will be mini, not min, right? Okay, so let's test it. So yeah, it is running fine. Let's submit it. Yeah, so it gets accepted. So thanks for watching. Subscribe to the channel for more such videos. Thank you.